Welcome back. Let's see if we can calculate some of the normal probabilities that we saw in the last video. Recall that we were working with a mean of 75 and a standard deviation of 19. We'll start with the simplest probability. That is a left tail probability. Here, we'll use an x value of interest to be 60. Now, to get us started, let's link that back to a z-score. So we'll calculate the z-score for 60. Recall that the z-score will tell us how many standard deviations above or below the mean our x value of interest is. So we start with the parentheses, go to 60 in B5, subtract out the mean in B1, close the parentheses, and then divide by the standard deviation in B2. That gives us minus 7.9, which means it's not quite one standard deviation below the mean. And then, as I've done, and I will try and do, is every time I create a formula in Excel, I will put that formula to the cell to the right in column C in this case. Okay, so we know it's below the mean, and we know that the probability, therefore, is going to be less than 0.5, since half the values are below 0.5. So now we use the norm distribution function. I'm going to type it in, but you could get that from the, actually, let's do that from the formulas, insert function. This is a great way to find formulas quickly. Under the category, we'll use statistical. Under statistical, we'll drop down to the function I mentioned, which is norm distribution. You may or may not see a period in older versions, so just be maybe norm dist. Okay, we say okay here. The x value is 60. The mean is 75. The standard deviation is 19 in B2. And then we want to put a 1 here to show that we have a cumulative probability distribution, which means all the values to the left or below 60 all the way through negative infinity. Maybe we'll take that down to, most statisticians use 4 decimals, and then we will make that formula appear in column C. And I hope I've done that enough. If I do it correctly, there we go. So there's our first probability in Excel. Maybe I'll underline it to show the column headings. And then when we read from that, there's about a 21.5% chance that a random house price will be below $75,000. So our next probability is a right tail probability. And there's 3 that we'll calculate today, which should cover most of the situations you might encounter. Now, while I'm here, I'm going to do a freeze pane. We've done that before. And what that will allow me to do is slide up and down so that we can see more of the screen. I'm sorry, that's incomes in the cell above. Okay, now our new x value of interest is going to be 100. Just to reinforce, and we won't do this much more often, but we'll calculate the z-score for 100 in the same fashion that we did when we calculated the z-score for 60. And note that if you're thinking about this, since the z-score for 60 was negative, you can probably figure out that the z-score for 100 should be positive. And we can take those decimals down a little bit. 2 or 3 is more than enough. And this should be essentially the same formula that we used to get the z-score for 60, except that it's now positive. So here is where the little bit of a trick comes in, and I'm kind of walking through this a little bit slowly for you. What is the probability that x is less than 100? And we can use that same norm inverse formula. Insert function. Now if we switch from statistical to most recently used, we'll see the norm.dis pop up at the top of our list. And this is just for your benefit if you're doing several calculations in a row using the same function. Our x value is now 100. Our mean is still 75. Our standard deviation is still 19. And here, we always want to put 1 for logical. So what that means is that there's a 90% chance that, or a little bit more than a 90% chance that a random income will be less than 100. Put my formula in for reference. Now that's all well and good, except for the fact that we were interested in the probability that an income would be greater than 100. So we'll just change the sign here. And for this formula, rather than there isn't a function for the right tail, we'll simply say that's equal to 1 minus the value we created above. Right, do that correctly. And just to keep that in mind, put that over there. And there we have it. So this is a complementary probability based back from basic probabilities. So there's a little bit less than a 10% chance that a randomly drawn family would have an income greater than 75. All right. So now we'll calculate a new probability. Scroll up a little bit just to kind of keep the reference. And we'll call this a middle. I'm going to put tail in parentheses because a middle probability. I'm not going to put tail in parentheses. And the middle probability is just what the name suggests, in that it is between two values. And just to keep it kind of real, we'll have our x high value of interest to be 100 and our x low value of interest to be 60. We'll fix the spelling here, although I wouldn't spend too much time on window dressing until your final version. So now, what we want to do, again, keeping in mind that Excel and most statistical packages give you a cumulative probability for a particular x value of interest and all the area to the left. So we're always kind of working with left tail probabilities. So now, rather than calculate z-scores, we're going to go right to calculating the actual probabilities. And just for reinforcement, I'll use the formula insert function again. Our x value for the high end is 100. The mean is still 75. Standard deviation is still 19. Still a cumulative of 1. You recall that value from before. We'll bring it down to 4 decimals. Copy that formula over. Now we'll repeat that process for an x value less than 60 or equal to. It's a continuous distribution, so it doesn't really matter. But I will reinforce the norm dist function again. Our x value now is 60, and this is nothing different than we did before, other than a little bit of practice for you. There's that same probability. Take the decimals down. Okay, those numbers we've seen before. What's the next step? Take the difference between those two numbers. Simply the B25 minus B26. That formula is very easy. And now we've calculated a difference probability. We'll save this one and pick up at this point in the next video.